Okay, how'd you do with this one? A little different, but not too terribly difficult. What I've done is I've put the finished part program up here. So take a look at that. It's also printed up in the documentation. This is the page number 30 in the manual. So you'll find the solution for page number 30 exercise in the manual. And let me just run through it real quick. For the outside, I've labeled points 1, 2, 3, 4, 5. For the inside circle here, it's a radius of 1.5 inches, and there's point 20, 21 right there. Now there's a slot right here, okay? It's got a full 180-degree arc at each end of it, and it extends from -4 inches in the X to +4 inches in the X. So very quickly, you're familiar with the G90, G20. Now we've turned on our spindle with a S500 M3, so we've turned on the spindle at 500 RPM. Now we're doing a rapid move to X-7, Y-3, so we're going right here over the edge of the part. That's -7, Y-3. We're feeding our Z down to a depth of 1.5 inches. You may have used a different number. I probably didn't tell you what thickness the material is, so in this case, if we were to draw the front view, we would see it at 1.5 inches thick. So we would see our hidden features right here. And then we're moving up, still in G01, up to here. Then we're making an X- move, Y 7.0 puts us right there. Now we're going to X positive 7.0, puts us right there. Now we're going to Y-3, puts us right there. And then back to X0, puts us right back here. So there's the moves we made. We started here, worked around, ended up here. Now we lift the Z up to 5.5 inches. We position it to X minus 3.5, Y minus 0.5. If you remember, I told you that was where the center of the circle was. Now we're feeding the Z down, so we're sitting in the middle there. Now we go to X minus 2, so now the cutter's right there. Now we're doing a G03, full 360-degree arc, right back to the beginning point. Temporary location is there, so the circle center is relative I minus 1.5 from where we are. If we're sitting right here and this is our circle, the center is at the minus side of 1.5. We wrap it up in Z. Now we position at X minus 4, Y plus 4, so we're sitting right there. We're bringing the Z down to minus 1.5 again, and now we're making a G01 move over to that position. So now take a look at the line. G02, X4, Y2, I0, J minus 1. Well, because we're sitting here, we know it's a G02 move, and we're going to X4, and this point is at Y 2.0. But now look, the circle center is relative to this start point in the minus direction in Y, and it's at the same location in X. So therefore it's I0, J minus 1.0, or whatever the radius is. And then we're doing a straight line move over, that does the arc here, and then it's G3, of course, or G02, I'm sorry. And now we're going to do the same thing. The arc is going to swing back up to here. But now, if you look at where we are, where the circle is relative to where we are, it's in the plus direction, right? So therefore, our J becomes positive 1.0. And then it pulls the Z out and goes to X minus 12, Y 0, somewhere right here, just to bring the cutter out of the way. Turns off the spindle with M5, ends the program with an M30. And I'm sure that's what you got. And now we'll go take you out to the machine and just take a look at this job as it's executing. And hopefully you can maybe dry run a part in your machine as well using this program that we set up. If you return to page 29 in your manual, you'll see a little write-up of an example of calling up what we call tool length offsets. Now, what tool length offsets are, and we haven't really talked about this yet, but if you consider that in the machine, spindle is a tool, as we see numbered. We see here in the red that there's a tool loaded in the spindle. This could be an end mill, it could be something. But there we say is our datum on the part, would be the top surface. And then there's a tool. Now you have to realize that if we have a spindle in a machine, this is the spindle, and when you saw that we were running a part, that the tool sits in the spindle some distance. We don't know how long the tool is going to be sticking out from the spindle, because we simply, as you saw when we were doing the setup, inserted the tool into a collet, locked down the collet. So that means that we have a tool here. We'll call this tool number 1. And most programs, although it would be nice to only have to use one tool, we generally use more than one tool. So for instance, if this were an end mill, and here what I'm going to call tool 2 is a drill, each of these is sticking out a different length from our spindle. So what we have to do is we have to actually, as part of our setup, you saw me demonstrate that, we have to measure the different tool lengths as they're sticking out. But in our program, what we need to do is we need to call up. So if we're calling this end mill tool number 1, the letter T with a 1, and we're calling this drill tool number 2, the letter T with a 2, if we're going to use tool 1, we'll have to call up the length that we measured and stored in the control to use in our program. So what we're going to do is we are going to substitute every Z move that we did here and that we've been talking about assumes that we have only one tool and not measured its length and have just used it without consideration for what its actual length would be sticking out of the spindle. So what you need to do is be aware that as part of the setup, we have touched off the tool to the top surface of the part, for example, and on the control we stored that register. Now, we stored the value of the tool in register 1, and then we stored the value of the drill in register number 2. Now we need to call up those registers in our part programs. So what we're going to do is we're going to associate tools with part programs. And if you notice we did a G01 Z move positioning down, all you have to do is substitute the number 43. You say G43 Z minus 1.0 instead of G01, and then you call up something known as the tool length registers, the letter H, and the tool number that you stored with the length of this tool in number 1. So H1 is a new register that we call up. This part program only uses one tool, so there'll be no need to call up a second tool. Now, all this H1 does is it calls up the value that we stored for tool 1. It does not actually load tool 1 into the spindle. If you have an automatic tool changer on your machine, you would add, just before your spindle speed, you would add this. You would say T01 and then M6. If your machine is equipped with a tool change arm, M6 will put tool number 1 into the spindle. So now I just want you to be aware that you use the G43 with an H word to call up whatever stored value we have associated with the different tools that our job will be using. So now as we move through our programming samples,